All right, welcome back. So today we are going to do a question called 3-sum. All right, let's get into it. So the question is, given an array nums of n integers, are there elements a, b, and c in nums such that a plus b plus c equals 0? Find all unique triplets in that array, which gives the sum of 0. So for example, look at here. All right. Given the array number, if you get -1, 0, 1, 2, and -1 and -4, as you can see, this is not sorted. And then the solution would be -1, 0, 1, -1, -1, 2. And yeah, that's pretty much it. The reason why is because -1 plus 0 plus 1 equals 0. And -1 plus 2 equals also 0. So you want to find all the set that is that sums to 0. Now, you have to make sure that the solution must not contain duplicate triplets. So here you see there's 2 negative ones, right? So imagine if you took the permutations of them. If you care about the uniqueness of the -1s, then you might get 3 solution set, which is you would have 2 minus -1, 2. But here we do not want the duplicates. So even though we have 2 -1s, you don't want them. Okay, cool. That's right, sounds good. Now, how do we do this? So this is actually a pretty good question. If you think about it, you can think about what the brute force way is. So the brute force way, it should be pretty easy. What you could think of is try all the possibilities. So how would that look like? It would probably look like, okay, for I, j, k, where I, j, k's unique indexes, you sum them together. And then if it's 0, then that's a solution set. If it's not, then it's not. We can actually code this up pretty quickly just for the sake of it. In case you guys don't know how to do like brute force way, it's not a bad idea to play around with it. So you have for I in range length nums, let's just do -2 because you're gonna have to leave space for the other one. And then for j in range I to length nums -1, and then for k in range j length nums. All right, so you have a triple loop, and then what you want to do is you want to check if nums I plus nums j plus nums k is equal to 0. If it is, then what you want to do is you want to add that to the result. So we have one result away. So then result append nums I nums, it's going to be an array, so it's going to be like this, nums I, nums j, and then nums k. All right. Yeah, so we can also make this a set because you don't want duplicates, but for now I'm just going to run it. Yeah, here we have a bug. Because j can be I, so they can all be the same number, but we cannot because they have to be unique numbers. All right, and here's another bug because we have duplicates here, because we have kind of like what we said before, the -1, 0, 1 cannot be the same. So what you can do is you can kind of like sort this array first. All right, perfect. And then now that it's sorted, you could check for uniqueness. So here it can be a set instead. And then you want to return into a set into an array. I forgot how to do that. How to set into array Python. All right. So then if we run this, technically it works, but then yeah, time limit exceeded. So that's like the brute force way. So now we have to think about some way that's better. So obviously we can see that we've been doing a lot of like computation that we could have like easily not have. Let's go to the iPad and look at how we can do this instead. So, all right, let's take an example. Let's take the same example here. So the key is we have to do something called 2-sums. Now, if ever, I'm not sure if you guys know what 2-sum is, but it's a very similar problem. But instead of 3 numbers, it's 2 number. So give 2 numbers such that the value is 0. So we've done this technique before. It's using 2 pointers. So let's look at what 2sum is. So imagine we have this array. First of all, 2sum, we need a sorted array. I'll show you why that's useful. So let's sort this array. So it becomes -4, -1, -1, 0, 1, 2, right? And then what 2sum actually does is you have 2 pointers. 1 pointer here and 1 pointer here. So we'll call this like the left or the right, or like the I and the J pointer. And what you want to do is you want to keep that sum in mind. So currently the sum is -2, right? Currently the sum is -2 because -4 plus 2 equals -2. And then in 2sum, if you know that the number is smaller than 0, then you want to increase it. How do you increase it? Well, because this array is sorted, then you could increment this pointer, because there's no reason to increment this pointer to the left because you only have smaller numbers, right? So you want to, because this one is a negative number, you want to increment this guy, right? So you're going to take that out, and now it's going to be here. So now 2 minus 1, what is that equal to? That is equal to 1. Awesome. And then because 1 is bigger than 0, which one do you want to increment? You want to increment this way, or more like decrement, because you want to go lower in numbers, in sum. So it becomes like this. And then -1 and 1, that's perfect. It gives 0. So now you have one answer, right? And then you just do that again until they meet. Until they meet, and then you stop. So then here you could have that again, and then you actually get duplicates. I'll teach you how to prevent duplicates. But first, we'll see how to leverage this concept into 3sum. So yeah, so in 3sum, 3sum. But yeah, so in 3sum, basically what you want to do is you want to use 2sum given that you already have one index that's fixed. Like imagine if you have this index fixed, right? Let's say that's index like I. Then what do you want to do? How can you figure out the 3sum? Well, you know that it's -4, then what you need is, if you can have 2sum here, but instead of searching for a 0, you're searching for a 4, because you know that 4 plus -4 equals 0. So then you call 2sum, but a modified version of it. So you call 2sum 4, for example, on this array. So that means you're looking for a 4. So can you get a 4? I mean, quickly glance at it, you know you can't get that. And then after you realize there are none of these, we increment. We increment to here, right? So now I is -1, and then you do the same thing, but for this part of the array, and then what 2sum, you want the 2sum of 1. So you want to check if there's a combination of 2 pointers where you can get 1, which there is. It's this one, and also this one, right? So yeah, so it's either -1 plus 2, yeah, this guy, or this guy, right? So then these guys will give you, because I is fixed as -1, so you get -1, 0, 1, and also -1, -1, 2. Right, so you get these 2 answers. So that's pretty much how you can leverage 2sums in this 3sum problem, is by fixing one number and then calling 2sum. So what is the time complexity of this? So first of all, you have to, they have to go through all of the array. So that's O of n, right, to go through all of the array. And for each one of these O of n, you want to call 2sum. So it's basically n times the complexity of 2sum. And what is the complexity of 2sum? Well, let's see. You have an array, and you have 2 pointers, and you go this side and that side until they meet. So that's also O of n. So this together gives you the time complexity. Time is O of n squared, and then space, because it is done in place, it's O of 1, so it's constant. So this is pretty much the optimal solution. Yeah, so that's pretty much it. So we could start coding it up. First, let's write the 2sum. I'll just put a comment here. 2sum is this. and then and to sum. Okay, so imagine we have an index I that's fixed. Okay, let's just imagine we have an index I that's fixed. So, okay, so what do we want? We want the two pointers, we'll call it J and K. All right, and then J would be I plus 1. So imagine I is already fixed, okay? So then K would be length of nums minus 1, right? Because you want it to be at the other point. And then to sum, what it does is while J is smaller than K, you want to know if all of these numbers, if they're all together or equal to 0, then that's great. You're going to want to append in the result. So let's have a result array. Okay, we're going to have the result append these numbers, right? Nums 1, I, nums J, nums K. Awesome. Did I miss something? Yeah, okay. All right, and then like we said, if ever it's bigger than 1, then we decrement this way. If ever smaller than 1, then, or like smaller, whenever it's bigger than 0, we decrement this guy. Whenever smaller than 0, we decrement that guy. So while J, well, they're not touching each other yet, and nums J equals to nums J plus 1. Oh, so before decrementing, this is how we prevent having duplicates. It's if you see the same number, just go all the way to the end of that number so that you don't use it twice, right? So this is what it's doing right here. Okay. And then we'll also do it to the other side. Okay. There seem to be a lot of typos I'm doing. K minus 1. Okay. And then we'll decrement. This should be here. Like this. Okay. So that's if you see that you have a number that you like, or like you have a triplet of numbers that sums to 0. So that's perfect. And then once you append it, you're gonna decrement and increment until it's not duplicate numbers anymore. And then after that, what do? You decrement one more time or increment one more time. All right, perfect. And then, all right, and then the other cases is if it's bigger than 0. Plus nums J plus nums K is bigger than 0. All right, so if it's bigger than 0, what do? If it's bigger than 0, then we want the right side to go to decrement, so we decrement. And then the other case is if it's smaller than 0, then we want J to increase. All right, awesome. So that's pretty much 2 sum. Now what we have to do is we have to make it 3 sum. All right, so 3 sum, what we do is we just want to fix one number, right? And then once we fix that number, we call 2 sum. Here we already did it for you. We do I equals plus 1. It means the J, the 2 sum starts at after the number I. So let's fix I, and then let's iterate with I. So for I in range, what's the range that we want? Until length nums minus 2. The reason we do minus 2 is because we're gonna have 2 other pointers that are ahead of it. So you can't go all the way to the end. Okay, awesome. Let's remember when we talked about duplicates. Yeah, we have to handle duplicates here too. So if I is bigger than 0, and if it's the same thing, then we're gonna keep incrementing, right? And then if we continue, we just keep incrementing. And then, yeah, so that's pretty much it. And then this 2 sum should be inside this loop, because for each I, we're gonna call 2 sum every time. All right, let's see if everything is good. So if I so if there's duplicates, we continue. If not, then we call 2 sum, and then at the end of 2 sum, we're done. And then we just return the result. Let's see if that works. Does not work. Did I not append? Okay, I definitely did append. Let's see how many times do we append. All right, so yeah, usually you can't console log in the interview, so, but yeah, let me see what's happening. Yeah, so usually it's very possible that you get a bug during interviews, and what you should usually do is you should actually just like read it or like test it by hand. Like you just pretend to put numbers in and then output whatever. Usually the interviewer can already spot the bug because they've been reading your code, and then they're able to kind of like give you hints, and they actually don't really care much about bugs as long as the actual algorithm is good. They'll just point it to you to make sure if you can find it or not. But yeah, okay, let's see. Why can I find this bug? Oh, we forgot one thing. So we also forgot to sort these numbers first, because for 2sum to work or 3sum, you have to sort it first. So that's one thing. Yeah, okay, cool. And then we submit it. All right, this works. So that's pretty much it. And yeah, I hope you enjoyed that, and hope you learned something out of that. And yeah, see you next time. Thanks for watching.